So here we are, section 7.5, parts of similar triangles. The first thing I suggest you do is if you have your textbook with you, just copy all three theorems right off the bat, for the first three at least. There's a fourth one, but just copy those three. This is a very theorem-heavy section. We'll do a lot of the examples in class, but I am going to go through a couple at least in the video here. So today we're talking about parts of similar triangles. And for these parts of similar triangles, basically it's the fact that we have angle bisectors, uh, medians, and altitudes of triangles and how they're similar and proportional. And there's this fourth theorem, the triangle bisector theorem. So, first theorem 7.8. Again, if you don't have this, if you don't have your textbook, just pause it real quick, copy it down, and then go on. But if two triangles are similar, the lengths of the corresponding altitudes are proportional to the lengths of the corresponding sides. What that means is this. Okay, I've got a video for you here, or an example for you here. I've got two triangles. These two triangles are similar. Okay, and I have the altitudes drawn in EF and F and EG, and DE corresponds with side AE and BE corresponds with side CE. Those two sides correspond. So in this drawing, when I move this around, the ratio of the sides is the same thing as the ratio of the altitudes. So move point C around. Well, in this case it doesn't change, but I have to point B. No, B doesn't do that either. A doesn't do that. That's weird. So yeah, there we go. Move point D around. That'll change the ratio. But either way, they're still the exact same. So the ratio of the altitudes right here is the same as the ratio of the sides. Okay. Next theorem, theorem 7.9. Same exact thing. This time, hey, you've got two triangles that are similar. Okay. And then you're going to have angle bisectors in there. So LP and RT are a couple of angle bisectors. Well, the ratio of the angle bisectors is the same thing as the ratio of the sides. So it says the lengths of the corresponding angle bisectors are proportional to the lengths of the corresponding sides. Basically, this means whatever ratio you have for the angle bisectors is the same thing you would have had for the sides. So again, this time I have the same kind of drawing. Hey, but now I've got angle bisectors. So these angles have been bisected. And now GE is the angle bisector, EF is the other angle bisector. As I move this point around, the ratio of the sides ends up becoming the same thing as the ratio of the angle bisectors. So I can draw and change that and move it all around. But here we go. Angle bisector ratios right here. Side length ratios right here stay the same. And then our third theorem, theorem 7.10, same thing as the other two basically. This time again, two similar triangles. And what we also then have is we have medians. So they go from a vertex to the midpoint of the opposite side. So CD and YZ. And just like before, the ratio of the medians, CD to YZ, is the same thing as any of the ratio of the sides. So I've got it marked here. Again, these guys are congruent. This is the midpoint. Congruent, congruent. This is its midpoint. Here are the medians, EF and EG. Their ratio is 0.62, and the ratio of their sides of this guy are also always 0.62. So AB over CD is 0.62, and so on. Okay, so those are those first three theorems. So here's our first example that you're going to have to kind of try to answer for me. I've got this problem here. The question is which segment should go in this little box here. Okay, so I've got these two figures. I've got the drawing up here. I know AB over FG equals BD over what? So it's going to come up in a second. Give the answer either A, B, C, or D for which segment you think goes there, and then I'll go through and do it. Okay, so here we go. Question is which segment goes into the proportion to solve the problem? Well, what we have to look at is we know we have two similar triangles, but the question is what type of segment do we have? Well, these two guys here go from a vertex to the opposite side, and they're perpendicular. That means they are altitudes. And that means that the altitudes are proportional. So let's see what sides they correspond to begin with. They said AB corresponds with FG. Okay, so these two guys correspond. AB corresponds to FG. So then, if AB corresponds to FG, BD has to correspond to GJ, which was D. So hopefully you said D. Okay. Now that you know that, the next question is, okay, solve for X. So that's your next question. Solve for X. So, either you can pause it or you got the notes, work it out, but it's going to ask you to say, is it A, B, C, or D for the length of FG, or solve for X. Okay. All right, so looking at this, I've got my proportion, AB over FG, so 21 over X equals BD over GJ, which is 9 over 6. And that's all we have to solve. I do encourage you to reduce these two. This makes it so much easier. 3 over 2. Okay. Now I can cross multiply. 3x equals 2 times 21, which is 42. Divide by 3. X is 14, so hopefully you said answer B. If not, well, not a big deal. We'll go over more in class. Okay. All right, then our last theorem, the triangle angle bisector. This theorem is a little more complicated. There are actually two forms of it, and that's basically what you've got in the notes. It says copy the first form down. So again, pause it if you need to, or copy it out of the book. And then you've got this other way to write it out. So there are two ways to write this out. And it's kind of what makes sense to you most, how you decide to solve the problem, how you visually see it best. So an angle bisector in a triangle separates the opposite side that it crosses through. Didn't say this, but that's what it's saying, crosses through, into two segments that are proportional to the lengths of the other two sides. Now again, this all seems kind of weird and complicated when you read it. But here's what you have. You have JM, angle bisector, and then you have one side that's cut into two parts, KM and LM. Well, there are two ways to write this up. You can say KM over LM, which is the part over the other part. It's similar to the other two sides of the triangle. And KM is adjacent to KJ, so we use that one as the corresponding part. So KM over KJ, or KM goes to KJ and LM goes to LJ. So KM over LM equals KJ over LJ. The other way, which is the second part for you to write into your notes, and this is the way that it just makes more sense to me, is to compare KJ and KM to each other. The two parts that are next to each other have to equal the other two parts that are next to each other. So KJ to KM equals, or sorry, they did KM to KJ equals LM to LJ. And here's a little, visualization of that so you can see it. So I've got it set it up both ways. I've got JK over JL, so 7.66 over 8, that's 0.96, and KM over LM, 1.8 to 1.88, also 0.96. Or I could do JK to KM equals JL to LM. They're both 4.25. And as I move point J around, it changes those proportions in the drawing, but I still get that those ratios are always equal. Okay. So this is the harder theorem of the two to sort out, and it's more so just visually difficult to sort out. So let's look at an example. All right. Use theorem 711 to solve for x in this problem, and I'm just going to walk through it. I'm not going to make you guess one because a lot of times people aren't the best at guessing these. So if you think you can do it, go ahead, pause me, work it out. If you're really lost, just watch me do it and copy down what I do. So here we go. Now, again, we start off, we have the angle bisector. That's what it's telling us right here. The angle has been bisected. So there are two ways you could sort this out. Again, the book always does this color matching thing, where here's the one part, here's its adjacent side, here's the other part that gets formed, here's its adjacent side. Okay. So it's up to you how you want to write it out. You could do x over 6 equals 15 over 9. That's the first way that the theorem's written out. part over part equals side over side. And again, this part corresponds to this side, this part corresponds to this side because they're the ones that they touch. Or you could do, which is the way I kind of like to do it, side over part equals side over part. I don't know why, just that way I just prefer for some reason. Doesn't matter either way. You're going to get 9x equals 90. Divide by 9. When you cross multiply, you get 9x equals 90. Divide by 9, x is 10. Same thing here. 9x equals 90. X equals 10. Doesn't matter either way, still works out. Okay. So there is section 7.5. We're going to look at a lot of examples in classes because it's not that they're super difficult, but it really helps to go through quite a bit. So if you have any questions, come in. If not, I'll see you tomorrow.